Hi guys, in this video we're going to solve the final exam. Let's do it. Consider the combination of 11 and a equal to 11 factorial over a factorial times 9 factorial. Find the value of a. From the formula of the combination, we know that 11 minus a has to be equal to 9. So a is equal to 2. Hence or otherwise, find the coefficient of the term in x to the 9th in the expansion of x plus 3 to the power of 11. Using the binomial theorem, we can see that the exponent of x is 9 when r is equal to 2. So we plug in to the formula r with 2 and solve the expression. Remember, the coefficient is only the number, so we forget about the variable part. This was a common mistake in the exams. Sergey is training to be a weightlifter. Each day he trains at the local gym by lifting a metal bar that has heavy weights attached. He carries out successive lifts. After each lift, the same amount of weight is added to the bar to increase the weight to be lifted. The weights of each of Sergey's lifts form an arithmetic sequence. Sergey's friend, Yuri, records the weight of each lift. Unfortunately, last Monday, Yuri misplaced all but 2 of the recordings of Sergey's lifts. On that day, Sergey lifted 21 kilograms on the 3rd lift and 46 kilograms on the 8th lift. For that day, find how much weight was added after each lift. We can set up a couple of equations by using the nth term formula for the arithmetic sequence. After that, we have a system of equations. You can solve it by using the elimination method. In the end, we can see that d is equal to 5. For that day, find the weight of Sergey's first lift. We can easily plug in the value of d into one of the 2 original equations. We can see that the first term is 11. Let f of x equal px cubed plus px squared plus qx. Find f prime of x. This is a simple application of the power rule. Just bring down the exponent and then subtract 1 to the exponent. Given that f prime of x is greater than or equal to 0, show that p squared is less than or equal to 3p cubed. For this problem, notice that if f prime of x is greater than or equal to 0, it means that it has at most 1 root. That means the discriminant is less than or equal to 0 because this expression has only 1 root or 0 roots. After we set the discriminant less than or equal to 0, we can manipulate the expression until we find what we're looking for. Remember that the discriminant is only used with the coefficients, not with the variable parts. This was also a common mistake in a lot of exams. Consider the function f with derivative f prime of x equal to 2x squared plus 5kx plus 3k squared plus 2, where x and k are real numbers. Show that the discriminant of f prime of x is k squared minus 16. For this expression, notice that the coefficient a is 2, coefficient b is 5k, coefficient c is 3k squared plus 2. Plug in those numbers into the discriminant and then simplify. Given that f is an increasing function, find all possible values of k. If f is increasing, then f prime of x is greater than 0. That means k squared minus 16 is less than 0. We can solve this expression by adding 16 and taking square root. Remember that k can be positive or negative, so that means absolute value of k is less than 4. And if you remember, that is equivalent to negative 4 less than k less than 4. A cylinder with radius r, height h, is shown in the following diagram. The sum of r and h for this cylinder is 12 centimeters. write down an equation for the area of the curved surface in terms of r. We can see that the curved area is equal to the height of the cylinder times the circumference of the base. So that is 2 pi r times h. And we use the relationship of r plus h equal to 12 to replace h with 12 minus r. Find the derivative of a with respect to r. This is again a simple application of the power rule. Bring down the exponent and then subtract it by 1. Find the value of r when the area of the curved surface is maximized. This is an optimization problem. Set the derivative equal to 0 and then solve for r. Let f of x be equal to x cubed minus 2x squared plus ax plus 6. Part of the graph of f is shown in the following diagram. The graph of f crosses the y-axis at the point P. The line L is tangent to the graph of f at P. Find f prime of x. Again, this is a simple application of the power rule. Just bring down the exponent and then subtract it by 1. Remember that the derivative of a constant is always 0. Hence, find the equation of L in terms of A. So for the equation of a line, we need a point and we need the slope. For the point, notice that f of 0 is equal to 6. For the slope, notice that the tangent is at x equals 0. So f prime of 0, which is A, is going to be the slope. Hence, the equation is y minus 6 equals to a factor of x. And then solve for y. The graph of f has a local minimum at the point Q. The line L passes through Q. Find the value of a. First of all, because Q is a minimum point, we know that the derivative has to be 0 at this point. On the other hand, L passes through Q, and Q is a point in the function f. So we can set the function equal to the line. We can isolate x to find the intersections. We can see that there's two intersections. X equals 0, which is point P. So then x equals 2 has to be point Q. By replacing 2 into the derivative, we can then solve for A. A small cuboid box has a rectangular base of length 3x centimeters and width x centimeters, where x is greater than 0. The height is y centimeters, where y is greater than 0. The sum of the length, width, and height is 12 centimeters. Write down an expression for y in terms of x. For this problem, we know that 3x plus x plus y is equal to 12. Using like terms and solving for y, we can clearly see that y is equal to 12 minus 4x. The volume of the box is v centimeters cubed. Find an expression for v in terms of x. So the volume of any box is height multiplied by width multiplied by depth. So 3x times x times y. Simply replace y with the expression from the previous answer. Find the derivative of v with respect to x. This is an application of the power rule. Simply bring down the exponent and subtract it by 1. Find the value of x for which v is a maximum. We can simply set the derivative equal to 0 and then solve for x. Justify your answer. There's really two ways that we can do it. The first way is to find the second derivative and evaluate it in the maximum that we found. Because the second derivative evaluated at this point is negative, we know that the function is concave down, which means it's a maximum. An alternative method is to do a sign chart for the first derivative. We can ignore the answer x equals 0 because x has to be greater to 0, as is one of the conditions in the problem initially. We can do a sign chart with a number before 2 and 1 after 2, And notice that the sign change tells you exactly what type of critical point this is. It's increasing first and decreasing after, so it's a maximum point. Find the maximum value. Simply replace the value of x that you found before into the formula for the volume. Let f of x be equal to 1/3 x cubed plus x squared minus 15x plus 17. Find f prime of x. This is another application of the power rule. Simply bring down the exponent and then subtract it by 1. The graph of f has horizontal tangents at the points where x equals a and x equals b. A is less than b. Find the value of a and the value of b. Because the tangents are horizontal, that means the slope is 0. We can set the derivative equal to 0 and then solve for x. This is a quadratic. We can simply factor it and we will have the answers x equals -5 and x equals 3. Notice that a is less than b, which means a is -5 and b is 3. Sketch the graph of y equals f prime of x. We have 3 points that we can use easily. The y-intercept by setting the derivative by evaluating the derivative at 0. So we know f prime of 0 is -15. And we have the x-intercepts. So we have the points -5, 0 and 3, 0. We can easily sketch a graph using these 3 points and the fact that this will be the graph of a parabola that opens up. Hence explain why the graph of f has a local maximum point at x equals a. If we look at the graph of the derivative, we can see that at x equals a, this graph goes from positive to negative, meaning that it's increasing before and decreasing after the point a. So that's why this is a local maximum. Find f double prime of b. This is again another instance of the power rule. Bring down the exponent and then subtract it by 1. Remember that b is 3, so you have to evaluate the second derivative at 3. Hence, use your answers to part D1 to show that the graph of f has a local minimum point at x equals b. Well, simply notice that the second derivative at b is positive, meaning the graph is concave up. By the second derivative test, we know that the function will have a local minimum at x equals b. The normal to the graph of f at x equals a and the tangent to the graph of f at x equals b intersect at the point PQ. Find the value of p and find the value of q. Well, because these tangents are horizontal, then the normal has to be a vertical. So the equation for the normal at a is simply x equals a, or x equals -5. Now the equation for the tangent at x equals b, since it's horizontal, we know it's going to be y equals something. To find that something, we have to plug in b into f. So remember that b is 3. We plug it into the function and find the value of f. We see here that y equals -10. Hence, the value of p is -5 and the value of q is -10. So that's it for this video. Remember, you guys can keep practicing by using the question bank. I encourage you to look at the topics where you had the most trouble and find questions for these topics specifically so you can practice. This is only the beginning. I'm sure you guys are going to do a lot better next time. See you later.